Good morning, everyone. I would like to welcome you all for the 6 days online FDP program on Gen-based hybrid deep learning approach on IoT. The Vinayaka Mission Kripananda Arya Engineering College. It takes immense pleasure to welcome Dr. S. Rajanarayanan sir for the welcome address. Welcome you, sir. Sir, it is audible, sir?
Yes, madam, it's audible. It's audible.
Okay.
Arulmani madam, shall we start, ma'am?
Yes, sir. Good morning, everyone. I would like to welcome you all for the 6 days online FDP program on Gen-based hybrid deep learning approach on IoT. So I take this opportunity to welcome Dr. S. Rajanarayanan sir for the welcome address.
Arulmani madam.
Sir Rajanarayanan sir, it is audible, sir?
Voice கேக்குதுங்களா?
Yes, sir. We can able to hear your voice, sir.
Okay, ma'am. Okay, ma'am. Okay, we will start. So it's a nice good morning to everyone. So esteemed dignitaries, distinguished faculty members, researchers, and dear participants. Also, I welcome and a special welcome for our international participants. That is one of the international participants from Philippines is also there. He has also enrolled in this FTP. So first of all, I want to express my heartful thanks to our management, Vinayaka Mission Kripananda Arya Engineering College Chairman Dr. Sravan sir, then our principal Dr. R. Sasikumar, and Vice Principal Dr. M. Nitya ma'am for a given and a concern to conduct this FTP. So it gives me an immense pleasure to welcome you all for the 6 days faculty development program on a GAN-based hybrid deep learning algorithm for IoT. Today, as we gather to explore the frontier of an artificial intelligence and machine learning, it marks a significant step in empowering education and research with a cutting knowledge and skill that shape the future of technology. So once again, I extend my heartful gratitude to our keynote speakers, resource person who have come together to make the program as successful. So once again, a warm welcome to each one of you who are enrolled in this FDP. Now I I welcome our Vice Principal ma'am, Dr. M. Nitya ma'am, to give an felicitation address to FDP program. Thank you. Thank you. Welcome, ma'am. Nitya ma'am.
Yes, sir. Yes, sir. I'm here, sir. Am I audible, sir?
Your voice is not.
Yes, ma'am. It is audible, ma'am.
Audible. Audible. Voice audible.
Sir, now am I audible, Rajanarayan, sir?
Audible.
Yes, ma'am.
It's audible.
Good morning to all present here. A warm and hearty welcome to each one of you present on today. It's a great honor for me to stand before you for distinguished gathering, whereas we celebrate the advancement in the field of deep learning, particularly the innovation and rapid involvement evolving in the area of generative adversarial networks in hybrid learning techniques. The field of artificial intelligence has witnessed remarkable transformations in recent years. And one of the most significant breakthroughs has been development in the GAN network, generative adversarial networks. The GAN has been revolutionary in the way of thinking about the machine learning, which providing a powerful framework for generating a new data, solving complex problems in creative ways. From GAN, photographic realistic images to enhancing the data augmentation for various applications. It might be
டிஸ்டர்பா
and emerged
இருக்குங்களா?
one of the most exciting domains in AI research. The hybrid model is almost a combined strength for different networks for deep learning paradigms, convolutional networks, recurrent neural network, reinforcement learning, among that other synergy with GAN to enhance the performance across the various domains included in computer vision and natural languages. Let us all embrace with the challenges ahead, push the boundaries of our understanding, and contribute to ever evolving landscape artificial intelligence. Together, we can build a future where these technologies has harnessed for gather greater to good. The possibilities are as limitless and our imagination. Once again, I thank to our principal and I look forward to the inspiring discussions and insights I will come to the emerging area of today. I also thank to coordinator Dr. Rajanarayan sir. He has putting a lot of effort to conducting this workshop in a great successful manner. Once again, I thank you all. Thank you.
Thank you, ma'am. Thank you. Thank you. So now I just welcome our principal sir to give a principal address regarding this faculty development. Welcome, sir.
Well. Very pleasant good morning to one and all present here. I would like to congratulate that organizers, that to Pencil Bridgestone, that the organizers and the other coordinator from our BMKV Engineering College, Dr. Rajanarayan, who took an effort for organizing this 6 days faculty development program on GAN-based hybrid deep learning approach for IoT devices. It is a multidisciplinary subject. So it's not only for computer science engineering. Many faculty members are going to getting benefited out of this 6 days faculty development program. And about our resource persons, I have gone through your that brochures and all resource persons are very eminent. They are very specifically, they are achieved something on the GAN-based hybrid learning and approach on IoT. So I request all participants to utilize this opportunity, getting benefit out of this 6 days faculty development program. That maybe you can take up research work on this area also. There's a good scope for this faculty development program for taking up the research work. Best wishes to one and all present here. Thank you very much. Have a wonderful day to you all. Thank you.
Thank you, sir. Thank you, sir. Thank you, sir. Just now I welcome. Just hand over the section to pencil with Mr. Arulmuri, ma'am.
Yes, sir. I take this great opportunity to thank college organizations, and it's my immense pleasure to welcome our today's speaker. Dr. Sasi Kumar sir is a designated academician and professor in the School of Electronical Engineering at Vellore Institute of Technology, Vellore. With the extensive experience in teaching, research, and academic leadership, he has made a significant contributions to the field of electronical and communication engineering. His expertise span a wide range of the topic, including the signal processing, VLSI design, and embedded system and wireless communication. Dr. Sasi Kumar sir is a well-regarding of his dedications to forecasting academic excellence and innovations, inspiring both student and colleague with his insight, guidance, and commitment to advanced knowledge. At VIT, one of the India of prime institutions, Dr. Sasi Kumar sir has been instrumental in shaping the academic and research landscape of School of Electronical Engineering. His portfolio research output has been including the numerous publications in high-impact journals and conference, and reflect his dedication to pursuing the border of technologies. Behind his academic contributions, he has actively contributed with an industrial partner and the academic peer to develop the solutions to the real-world challenges. Dr. Sasi Kumar sir has a teaching impact, hands-on learning, and interdisciplinary collaborations, equipping students with the skill and need to excellence in the rapid evolving demand on the electronical engineering. Welcome you, sir.
Thank you, ma'am. Thank you for the introduction. Am I audible?
Yes, sir. It is
Vanakkam, sir. Vanakkam.
Vanakkam, sir. How are you, sir?
Fine, sir. Fine, sir. How about you, sir?
Yeah, fine, sir. Fine.
Okay, sir. We'll start, sir.
Sure, sir. Sure. Does my screen is visible?
Yes, sir. You may
Mm,
proceed.
yes.
Thank you, ma'am. Thank you. As this is the first session, I thought instead of directly jumping into the title of the workshop, a GAN-based hybrid deep learning approach for IoT, first we need to address how the data is collected and how it can be used for learning architectures in IoT. So this session is completely focused on data collection in hybrid learning architectures. So let me introduce what is data collection first. So data collection refers to the process gathering information from various sensors, transmitting it to a central platform for performing processing and analysis. So this central platform can be a standalone server which can be located in the area of data collection, or it can be a cloud space where we can use any kind of an architecture like Lambda in AWS. So the sensors which provides these data will likely have temperature, humidity, pressure, motion, light intensity, and more. The collected data is often used for monitoring operations to detect issues, optimizes the performance of various fields such as manufacturing, logistics, healthcare, and environmental monitoring. So where are the various fields where data is collected? The first, obviously, the Internet of Things. So Internet of Things is not a precise word which covers a smaller area of coverage. Actually, this to say this is the entire spectrum wherever data is there. If it is transferred from one place to another place and then it is collected, it is cleaned, then the cleaned data is subject to any kind of uh, evaluation such as analytics, then we will use to call this entire spectrum as Internet of Things. So here, the Internet of Things is implemented for a variety of scenarios. One such as real-time monitoring, predictive maintenance, enhanced efficiency, improved user experience. So here, real-time monitoring always focuses on continuous monitoring of devices, systems, environment, enabling real-time insights and alerts. So wherever automation is there, those scenarios comes under real-time monitoring. So predictive maintenance, similarly, so all the data collected or analyzed. So based on the analysis, there will be a potential equipment failure that has to be addressed and reduce the downtime and maintenance costs so that in case if there is anything goes wrong, analyzing the same as soon as possible and taking predictive actions will reduce the entire maintenance and downtime cost and increases productivity. Next is enhanced efficiency. Using optimization, you can cover resource utilization, consumption of energy, and operational process through data-driven insights. So that is how the forecasting comes in. Forecasting, weather forecasting, or we can see the wear and tear of even a tire can be monitored through data collection. Improved user experience. This is regularly provided by having GUIs, wherever you have graphical user interface. So you can see even app which has been downloaded from Play Store used to ask whether you like the app or not. So it is used for enhancing the user's experience and providing an optimal solution to the same. The second comes environmental monitoring. So here we can work for the maintaining air quality monitoring, water quality monitoring, climate change monitoring, disaster management. So even you can take this recent incident that occurred in Wayanad, the natural disasters like floods, where if there is a proper system which is already implemented there, for sure those things are already predicted and we are able to manage the disaster effectively. Next spectrum is healthcare, where we are the present state we are having a remote monitoring patient system, wearable health devices such as smartwatches and tracking devices, medical device monitoring, which is used for industrial and hospitals, clinical research, collecting data from for clinical trials and medical research studies. The other industries where the data is collected or rising up in agriculture, manufacturing, logistics, and smart cities. So what are the types of sensors from where we can collect is divided into four spectrum. The first spectrum is physical principle. So we have resistive nature of sensing, capacitive nature of sensing, inductive nature of sensing, piezoelectric sensing, optical sensors, and magnetic sensors. These are generally the physical principles of detection is differentiated. Then we have application based. The application based is temperature sensor, humidity sensor, pressure sensor, flow sensors, level sensors, gas sensors, motion sensors, light sensors, sound sensors, chemical sensors. So the variety of sensors given here are the use case requirement. So for example, if I want monitor my sitting room, I can go with a temperature sensor, humidity sensor, and a motion sensor followed by light sensor. So these four sensors, temperature, humidity, uh, motion and light sensor we used to uh, support me by calculating the ambient of my room temperature. As well I can control the lighting and air conditioning in this room. Even if there is any intruder without my permission who enters into my room, it is detected through motion sensor. Next, based on output, what type of a processing technique I'm going to use, whether I'm going to work with analog data or I'm going to work with digital data. So obviously, the sensors data should be in such a way that we have analog sensors which provides analog output, and similarly digital sensors for digital output, binary zeros and one. The over the data generated by each type and their applications, as already we have found, one such an environment we can go with air quality sensor, noise sensor, sensors used in agriculture, which is able to monitor different level of air quality, different level of noises that are produced near airports, highways, urbans. Similarly, the sensors used for agriculture will use to automate the complete agriculture system. If some of the basic sensors which are used for agriculture are, we can have soil moisture sensor, temperature sensor, humidity sensor, gas sensors. Okay, so these sensors will provide us the condition of agri land where you are able to predict for in the first 6 months. After 6 months of data collection, you can analyze the data and you can check with what the land is able to cultivate for the next 6 months. And it depends on the type, whether it is a summer, whether it is winter, and so on. So through continuous availability of data, we are able to predict, so that this GAN architectures plays a major role in providing supporting environment for uh, improving the cultivation in agri lands. Next, data acquisition techniques. So what are the types, how I can acquire a data? So there are three. One is the direct measurement from sensors. So directly I can put a sensor connected with Arduino board or Node MCU or a Raspberry Pi, which is able to pump the data directly to cloud storages. Other than that, use of data loggers and gateways. Sometimes there is only one connectivity of for internet is available in the entire scenario. So there we need to follow the data collection through data loggers and gateways, where the data loggers and gateways alone will have internet connectivity, and remaining data collected from the environment will be through multi-hop techniques or routing. We use clustering, routing, and multi-hop technique, so that the data from all the ends reaches the data loggers as well the gateways. From the gateways and data loggers, we are able to push the data to cloud. Second and third is integration with IoT platforms or real-time data collection. So here, the entire IoT platform, for example, we can take about uh, deployment of forest fire detectors, where in forest, mostly the signal won't be available for data transmissions. So there will be an intranet which is deployed, so that through clustering process, the entire network is installed, and there will be forwarding nodes, or we call it as relay nodes, which integrates all the data to a single point. We call it a sync node or base station. From the sync node and base station, where it may be near the roadside, where it can get signal to reach a cloud. That is network signal to reach cloud. So through the integration of IoT platforms or real-time data collection, we are able to acquire the data. collecting data using direct measurement from sensors. So as already I pointed out, have the microcontroller board which is going to support calculating or receiving the data from sensor, and through this we are able to push the data to internet. So direct measurement is a general technique, and most of your projects, the student projects, you can see they used to collect data directly from the sensors. And here we have data acquisition, data processing, analysis. All are connected through a simple example we can take. I think most of you might have saw projects where students used to do for smart agriculture. So here we can go with one example so that it won't confuse. And then later I will give you other examples which are uh, having variety of applications. So the first, we thought of there student used to have a clay. The clay is monitored whether it is having any kind of a moisture. In case if the moisture content is very less, they used to put a relay there which switches on the motor when the moisture content reaches the threshold. So once the motor switches on, the entire clay in the pot gets watered. After that, the soil moisture content is again sensed. Once the threshold again reaches the maximum, for sure, the relay will cut off the sensor. And this is a small prototype where the entire environment works in processing the data in the scenario where it is installed itself. Here, there is no need for any cloud environment. So this kind of will have the key steps like sensor selection. So as I said, choose a soil moisture sensor, the sensor selection, sensor calibration, whether you need the data in terms of analog or digital, so that you can define. Similarly, data acquisition, put a Arduino node there. If it is an analog sensor, for sure, soil moisture sensor is an analog sensor. So through Arduino board, please collect the data, and then you process the data by setting up rules. So you can set when to switch on the relay, when to switch off the relay, so that the motor is turned on and motor is turned off based on the data which is received from the sensor. So collecting data using data loggers. So this is the concept we used to call it as edge computing. So for example, I need to monitor my classroom, and this classroom will have multiple sensors at every nook and corner. I can use, for example, let me go for detecting a fire. So for detecting a fire, I need to use fire detecting sensors in the classroom. So if the classroom is around 800 feet, for 40 plus 40 or any kind, at least minimum I need 6 to 8 sensors to be placed in the room so that I can monitor the entire, or I can cover the entire classroom, so that I'm able to predict in case if there is any abnormality. So here, all the 8 sensors which are being mounted on the roof doesn't need internet connectivity. So the data loggers or the gateway, which is one which is sitting at the end of the room or near to the walkway, which collects all the data from the sensors, and it used to push to internet either through a wired connectivity or a wireless connectivity. Mostly wired connectivity is preferred for fire detecting sensors. So these which are deployed at the edge, or we used to call it as where the node which has connectivity, which collects data from all the unconnected nodes to internet. We call them as data loggers and gateways. So you can see the associated definitions for gateway. Data gateways act as an intermediaries between data source, and central system. They collect data from multiple sources, including data loggers, and transmit it to the centralized platform. Either it can be a server which is deployed in the scenario where actual data is collected, or it can be in internet cloud where we use internet tools for accessing and analyzing the data. So benefits, the best benefits, or first thing is automation. So completely you can automate the entire area without any further manual efforts needed for the same. Remote monitoring, we can monitor from anywhere. Real-time insights. So real-time you can take additions. For example, if I want to go for monitoring street lights, So I doesn't need that when it is going to switch on. I don't want to check when to switch on the street lights. Once it is 6 o'clock, fine. But it is a summer day, for sure, light will be there. Sunlight will be there. If it is winter at 5 o'clock itself, the sunlight will be very dim. So if I put an LDR there, automatically I can make how to automate the entire system. So these are real-time insights. Then next is data integrity. Ensure data accuracy and reliability. For example, if I work with computer vision based pattern recognition techniques, I can buy a camera for 40 rupees. I can buy a camera for 400 rupees. So here, data accuracy is the key aspect which improves my algorithm and supports my reliable aspects in terms of reliability. So I need to prefer only for a 400 rupees camera where the data is very accurate than a 40 rupees camera which does the same. Next is scalability. In case if I want to extend the systems with more number of sensors. So in the previous example, I said I'm going to monitor my classroom. Instead of monitoring one classroom, I need to monitor 40 to 60 classrooms which are there in the entire environment. My system has to adjust either expanding or reducing the scale of connected sensors and devices. Collecting data using integration with Internet of platforms. So this already we have discussed that this is just a combination of both internet and internet. So internet where sensors used to send the data between themselves to one gateway node, and from the gateway node through using MQTT or HTTP, you can send the data to IoT platforms where we have two types of platforms. One is public cloud, second is private cloud. So the use of public cloud is public cloud will be available to all the users and anywhere around the world you are able to use. For example, you can see here AWS IoT Core, Azure IoT Hub, Google Cloud, IBM Watson. These are public cloud platforms which are accessible anywhere and they will be hosting region wise. The other spectrum is private clouds. In case in VIT, if I want to have my own data center, I don't want to go for public cloud. My data is highly private. I don't want to give it to any other than any private players. I have to hold it in my own. So I can create a data center here and I can use to send all the data which are sensed in the environment to my data center, and I work with my own engineers to see the insights. This comes under private cloud. So the advantage of public cloud and private cloud is in public cloud, what is the requirement? Based on the requirement, you can buy the space in cloud storage. But in private cloud, the problem is in case if you are expanding, the maintenance and buying extra servers and storage itself is too costly. And here the spend will be more high because I have to have my own data center, my own engineers, my own data analytical persons to see the insights and how I'm going to deliver. So here I need different sets of engineers supporting different areas of work, and as well I need to have a space. I need to have hardware. So here the amount of cost I'm going to spend will be very, very high. That is why public clouds are being used for most of the projects, and even for student projects also they cannot spend more, so they mostly use ThinkSpeak kind where we are able to have free access, and it is limited. We have both paid access as well as free access. With limitations, free access is provided. Next is edge computing platforms. So uh, we can take the classroom scenario where there are 8 sensors which used to collect the data, and these 8 sensors will put the data in the edge device which is there with the internet to send the data to data center. Fine. So here, instead of sending for sure the room in the room, in case there is no fire, all the 8 sensors are going to give the same data. So sending 8 times the same data will cause redundancy in data. So it occupies higher storage. The same data is repeated. No, if there is no fire, 0 will be sent. The 0 will be sent for 8 times. Instead, if I have an edge device differs from gateway device. Gateway device is not an intelligent device. It used to send all the data in sequence or in parallel, whatever it is, but 8 times the data is repeated that saying there is no fire. If there is an edge device, the gateway device can act as an edge device if it has intelligence. So what it does is it checks with all the 8 sensor data It finds there is no fire. It will send only one data. So in this particular classroom, the classroom is fine. There is no fire. This we call it as edge computing. So the advantages of having edge computing is for low latency, as only one data is sent, so low latency, privacy sensitive applications. So these are secure devices which are used for only sensitive applications, and the devices which are can support edge is intelligent devices such as Raspberry Pi, Arduino boards with IoT gateway. Next, data transmission and ingestion in the same part. So first, data is collected. Second, the edge device and cloud platform collecting the data, followed by data transmission and ingestion. So how the data is sent to internet. So here we have network connectivity. So network connectivity can be a Wi-Fi, cellular, LoRa, or we can go with uh, Bluetooth, Zigbee, whatever. Okay. So the network connectivity can be ensured through this, so that through this we are able to send the data to internet. Next, data protocols. We have lightweight protocols as well heavyweight protocols. If the data is digits, we can go with MQTT. If the data is image or live video transmission, we can go with HTTP to send the data to internet. Next is data ingestion. The data ingestion is used for time stamping your data with respect to the incoming format. So if I send, I can schedule the data when to be sent. For example, if it is a fire detector, it is going to send data continuously. If it is a temperature, I don't want to sense the temperature of this particular room every time or every second. I can just make an interval to send the data every 10 minutes once or every 1 hour once. It depends on the application scenario. Suitably, you can uh, create an interval to send the data. Next is data processing and analyzing. So here we use three kinds of methods. First is data cleaning and pre-processing. We cannot make sure that always the data received is in correct format. It had all the fields. As we have wired transmissions, we have wireless transmissions. For sure, there may be data errors. So here, data cleaning is nothing but uh, uh, there is a data which is having some formats which are not understood by the processor or the analyzing algorithm. So you need to remove those things. We call them as cleaning, and pre-processing used to remove the outliers and inconsistencies in the data. For example, I used to receive data from a temperature sensor which has to send 26 degrees centigrade or 30 degrees centigrade over a period of time. Suddenly, I receive 300 degrees centigrade in between. And this data is not actual data. It is an inconsistent data. It may be due to the sensor which sends the data, or while making the packet, transmission packet, the transmitter might have done some errors in it. So all this removing noise, outliers, and inconsistencies is the process of data cleaning and pre-processing. Next, data storage. So how this data is going to be stored, in what format? The data may be digit, or the data may be time-stamped databases such as InfluxDB, TimescaleDB, MongoDB, and so on, or it can be even an image. So the data storage platform will decide what type of a data it is going to get converted and stores in it. So how this data storage is designed, it depends on the type of analytical tool which you are going to use. For example, if it is GAN, GAN architecture will work with all kind of data. It works with digits, it works with images, it works with video. In the recent days, you can see the leaders were not there. Okay, the famous leaders were not there, but we are able to recreate by using your own content. You can recreate that those leaders are able to come up with certain idea and they are delivering. And I think so. Recently, we used to see Dr. Kalanyar and Dr. MGR's videos were there, which creates a lot of viral forwardings in all the social medias. Okay, these are just through GAN. We are able to make these kind of data through GAN, and it requires certain formats of data. So these formats decides what kind of a data storage that requires. Next is data analysis. So in data analysis, we have apply analytic techniques such as statistical analysis. You can go with machine learning. You can go with deep learning. You can go with. You can go for hybrid AI models, which extracts and the insights of all the data and trends, which leads to next real-time monitoring and alerting system. So this is where we finally end up. So you need to have a dashboard where you are able to monitor the conditions of data which is received, and after analytics, how I am going to project the data. So for example, we can have a smartwatch as an example here. So my smartwatch is able to collect the number of steps I used to walk, my oxygen level, my blood heart rate. Similarly, in case if there is any pressure sensor, I can monitor my blood pressure too. Okay, so right, this data is through Bluetooth. It reaches the application which is running in my mobile phone. Once after receiving it, it used to do the analytical part within it. The computing part is within the app. The app used to find what is my sleep rate, how many steps I used to walk, when my heart rate is rising, what is the oxygen level I have, SpO2 level I have. So after analyzing all this, it used to pop up and give you a notification in a colored fashion. We used to call it as graphical user interface. Okay, that is where the dashboard creation is. So every app will have its own graphical user interface, which provides you certain details. For example, you can see how WhatsApp works, how Telegram works. Both are used for the same services. But if you check with Telegram, the GUI is not much easier for a layman to use. But WhatsApp, anyone can use it. Just uh, a minute of training is enough for using WhatsApp. That is how the GUIs plays a major role. The dashboard creation plays a major role. So next is alert triggers. So these are the notifications which are given. For example, in terms if there is anything to be addressed, my oxygen level goes down. It need to be critically addressed. So that alert triggers. Next is notifications. So through in the top ribbon, you are able to view all the notifications of apps which you frequently use. So ads, or if I upload a new video in my YouTube, if you are the subscriber, you used to get the push notifications immediately that I have published a video. Okay, so through this, we are able to provide a real-time monitoring and alerting mechanism. Right. So what are the benefits here? Okay, so we looked over three types of data collection. One is direct data collection from sensors. Second is through uh, data loggers and gateways. And the third is the complete Internet of Things, where we used to see like the smart band, how it works, the entire data, right? So the benefits are enhanced decision making, predictive maintenance, optimized operation, improved customer experience, increased efficiency, and finally cost reduction. So these are the benefits when you collect real-time data collections using Internet of Things. Next. So what are the processing techniques which are involved in data processing? Cleaning raw data using smoothing techniques, normalization methods to prepare data for analysis, visualization techniques to explore data patterns and insights. So cleaning, we use several algorithms for it. It depends on how you need the data. So I need, I'm going to use facial recognition kind. Okay, so I need to recognize the face pattern of each user so that I can design a attendance system, a smart attendance system using facial recognition. So how I need the data? So the face mask has to be created. Okay, so the face mask, the camera can detect anything. Okay, if there is no one passing through, it detects wall. If someone passes through, it detects any part of who is passing through. It can be a human being, it can be an animal, it can be a bird, anything. So which data it has to look for? It should be a face pattern. So for it continuously monitors when face pattern occurs, and face pattern is detected and it is taken in. This is, we call it as data cleaning process. And here this is a live data process. What I said example is a live data process. Instead, I'm going to monitor the rainfall of a city. So for this, I need to have a data set for a longer period of time to be collected. From Jan to Jan, I have to collect it. So it has to be repeated for many years. So in this, you can see as the large amount of data is there, for sure, the data errors will be there. So these errors I have to remove. So what are the techniques available in this particular scenario? We have moving average, we have exponential smoothing, we have Schwarzschild GAN filter. So these are the different techniques which we use. So in this, what are the types which I'm going to remove are the noise type, data trends, and level at which the smoothing is to be occur. Okay. And one of the problem what we have is in terms of when you are cleaning the data, the over smoothing and under smoothing are the issues we have. So over smoothing, excessive smoothing have some important details and trends of the data are masked. Okay, I missed some data. Under smoothing, this will not remove the noises effectively. And data losses during the smoothing process, unless you correct the data to any upper limit or lower limit, the entire data will be lost. So, a better example for this is this mostly occurs in digital transmissions, not in analog transmissions, because in analog transmission, mostly we have some data is available at that format, and we used to predict based on the previous data or the next data. But in digital, it is all zeros and ones. If something is missing, the entire data is completely lost. As uh, in Internet of Things, the problem is you need to save everything. You need to save in terms of energy spent because all are mostly battery operated devices. You need to save bandwidth because every bit you transmit is costing in terms of energy. As already energy is addressed, it is related to how much data you are transmitting. For simply to say, uh, in wireless sensor networks, we used to calculate for every bit it consumes uh, uh, 2 joules. 2 joules is the default one we used to take. Okay, 2 joules it takes. So if every bit is consuming 2 joules, think about how much bits you are able to transmit in a battery operated device. So that is how if you frequently use your mobile phone, it loses its battery life as well. How it is happening? Because the amount of data which you use, which consumes a lot of battery. Next, normalization methods to prepare data analysis. So we have min-max normalization where x normalized is equal to x minus x min and x minus x max. So x is the actual data, x minimum is the threshold you keep keeping for minimal, and max is the maximum threshold you keep. So through this, you are able to normalize the data which is received. Numerical data has different scales. Next is Z-score standardization. This is another one where we used to go with using mean and standard deviation. The next is decimal scaling. So here, um, mm, decimal scaling mostly, for example, the applications where we use segregation in terms of levels 0 to 10. I can keep the level. If my received voltage is uh, 0.8, I can level it up to 1. If my received voltage is 2.3, I can level it up to 2, which is the nearest maximum. Okay, so this is decimal scaling. So the choosing the right normalization method will help in min-max normalization, which characteristics of data you would want to say. So min-max normalization suitable for the algorithms are sensitive to scale the input features such as neural networks. Mostly the neural networks will use min-max normalization. Z-score normalization is only used for linear regression and logistic regression. Z-score plays a major role. Decimal scaling is normally used for number systems. Wherever you want to find number systems where they, you can go with decimal scaling. The last part is visualization techniques to explore data patterns. So how you're going to visualize the data, in what, how I'm going to present my data. I have analyzed the data. Now I need to present the data. What are the types I can use? Histogram, box plot, density plot, bar charts. These are generally available data. Even for example, if you go to any Internet of Things project, how I'm going to present the data as a final output. The nodes are going to sense the data. The internet platform is going to host the data. Fine. How I need it? whether I need a report kind which I'm able to download through Excel format, or I need some visual representation such as image formats. So histograms, box plot, density plot, bar charts will give you a visualization thing where you are able to have the insights of data in terms of numerical and continuous data. Next is bivariate visualizations, where we have scatter plots, line charts, and bar charts. These are time-stamped data. The time-stamped data, if you want to check it, you can go with scatter plots, line charts, and bar charts. Next is multivariate visualizations. I need some more UI and UX how to play in this, user experience and user integration how to play. So I can go with heat maps. So based on the data, for example, temperature data you take or weather forecasting data, we can have heat maps so that we are able to visually impact the users, pair plots, the pairwise relationship between multiple numerical variables. If you want to compare two or more variables, you can go for pair plots. Parallel coordinate plots. This is used for high dimensional data where plotting data points in each line. Scatter plots, again, pairwise scatter plots for multiple numerical variables. So you can see the functional availability at various dimensions. If dimensions are high, we need to go for multivariate visualizations where there are numerical presence of variables at various dimensions. Then we have interactive visualizations, as you can see how the present day apps are giving. These are interactive visualizations. Dashboard is one kind and geospatial map is another kind. So dashboard generally all the available sensors in terms of visually, for example, if I want to check what is the water level right now in my tank, I can have the same thing digitalized and I can use a digital twin to show whether it is full, whether it is half tank, or it is having 1/4, or it is empty. Similarly, I can go with geospatial maps. So let me have another kind logistics. If I want to check logistics, where actually my logistic is. If I put it in a map and it is geotagged, there is a GPS sensor in the truck, and the truck is moving from one place to another place. Okay, how I can monitor whether it is coming towards or away. So this geospatial maps are the one which is used in Ola, Uber, and all these applications presently we use for higher taxes. Next, how to choose right visualization. What you need exactly. So data type plays a major role. Numerical, categorical, temporal, number of variables, whether you have single variable, two or multi. What are the dimensions of data presentation you need? Next, the preferred one is audience. Whether it is a technical person or a non-technical person. If he is a technical person, how he will be expecting. If it is a non-technical person, what are the things I need to provide additionally so that the app will reach or the visualization will impact the user. Finally, the goal. Why I have to do it? How to do it? Exploratory analysis will say why I need to. Hypothesis testing and presentation will say how I'm going to do it. So the popular data visualization libraries, we have Python, which uses Metapolyclub, Seaborn, Plotly, and followed by R. R programming is one of the one which you can go with using R Studio, which is a very good visualizer, and followed by JavaScript in case if you need power impactful visualizations, you need to go for D3JS, Tableau, or Power BI. So data analytical techniques, generally we have three. Signal processing. If your data need to be smoothened, you need signal processing. Next is future extraction to identify key informations. What are the insights you are looking for? Then the classifications. What kind of an algorithm you are going to use? A, ML, or deep learning? Which one you prefer? Okay, so these things are completely related to sensor types. You can just escape. So next is what is future extraction to identify? Yeah, we can more relevant to this workshop. Classification using A and ML algorithms. So classification will decide what kind of processing techniques you're going to impose. So generally we have supervised, semi-supervised, reinforced. Okay, so we don't want to get into that in depth because we are only focusing on GAN. So I will give you some related architectures. Support vector machines. SVM is a powerful classification algorithm that aims to finding optimal hyperplane that separates different classes. So what is this vector mechanism is? We have several kind of representations of data. So if there are parallel parameters or parallel enablers which you need to see the insights, it comes under vector mechanisms. Okay, so this vector machines will work on this multiple dimensional data and it predicts to the close for each class known as support vectors. So from a single data, there are variety of verticals where you need to look over. Okay. For example, we can talk about publications. So if I publish a paper, how many numbers I publish? What is my H index? How much citations I receive for the last 5 years? Similarly, what kind of a journals I need to look for? What is the future trend I need to work so that I'm able to boost my citations and there are more number of challenging works I can take up. This is all interrelated. These are the different vectors which I'm going to need. So you can see with a single name, there are many things associated. So with a single data, you are able to predict many things. Similarly, you can, if you are analyzing the data of how Vinaya mission is performing. So from a single sheet at various verticals, how the ranking agencies use a similar case, you are able to analyze. So for this, we need, if you want to analyze that several verticals, we need support vectors. So what are the advantages? Effective in high dimensional spaces. So we have multi-dimensional vectors. So this helps in analyzing the same. Handles non-linear data well through kernel tricks. So you cannot see a linear performance. There will be non-linear performances too. So this will handle it. Robust to outliers. This is the key aspect of having support vectors usage. The other type is neural network based. So where we can call A, all A's are neural network based. Neural networks are inspired by human brain are composed of interconnected nodes called neurons. They are capable of learning complex patterns and making accurate predictions. And here we have several types. One is these are general types of neural networks: feed-forward neural network, convolutional neural network, or recurrent neural networks. I think that most of you have already came through the CNN, KNN kind. So feed forward, simplest type where information flows in one direction from one input to another input. And here we used to adjust the weights so that the algorithm learns perfect. And over the period of time, it is able to start to predict after training. Convolutional, especially used for image and video data type. They use convolutional type to extract data features. Recurrent, mostly while processing a sequential data and predicting the same. So wherever we have timestamps, these are sequential data that can be processed through RNS. So here the advantages are high accuracy, complex tasks, ability to learn hierarchical representations, and can handle large data sets. So right algorithm choosing is the need of our how you will choose the right algorithm, which algorithm you need. I can go with CNN, I can go with RN, KNN, GAN, anything. How I'm going to decide it? The size and complexity requirements. How much data you're going to use? What is the complexity involved in the data? Next, future engineering. So how effectively you are going to see the insights? Computational resource. What are the timeline to train the algorithm? Second, how much complexity involved in training? How much space you need to store the data? What is the processing capability? So here the computational resource is a win-win situation created for hardware and software. So that decides which type of neural network you're going to use. Next is interpredictability. So this is used for complex neural networks where you need to see multiple dimensions without changing the data. Okay, that is where SVM models plays a major role in this. Instead of neural networks, SVM plays a major role here as the support vectors were there. Next is practical considerations, data processing, clean pre-processed data to remove noises and inconsistencies. Future engineering, how to improvise and informative data is collected from relevant information, that is relevant data. Model selection and hyperparameter tuning. Right. So uh, you can see there are many versions of YOLO. YOLO still, if you check with YOLO V3 to V11, there are different parameters, selections. You can tune it to user data and insights. So this is done through several tuning parameters, or you can see the convolution matrix is there, confusion matrix is there, where we are able to analyze true positive, true negative, false positive, false negative. So over this, we can tune it. Similarly, next comes model evaluation using appropriate matrices for tuning. So what are the things you want to improvise? I need a very good accuracy. I need a very good precision. I need to analyze the recall rate, EFN score. So this again will be mixed up with hypertuning parameters and so on. Next is underfitting and overfitting. This complexity is always there. If you tune more, it goes for overfitting. If you are not up to the approximation, it is underfitting. So the models usually plays a major role where uh, optimization is decided through model evaluation. So model evaluation will check what kind of model selections are made appropriate and hyperparameter tuning is required or not. And these are just to avoid overfitting and underfitting. So next is the predictive modeling. So for predictive modeling, what are the things I need to go for? Predictive modeling is a statistical technique that uses to predict the futures and the output. So generally, we have the common predictive models such as linear regression, logistic regression, decision trees, random forest, support vector machines, neural networks, navy Bayes, k nearest neighbors. Okay, so these are the general predictive techniques still we are using, and I think so in the upcoming sessions in related to GAN, you will see more. The thing why I haven't covered GAN is throughout the sessions you are going to hear about GAN. So first we need to know how data is collected, how data will be sent to internet, how data insights are being seen through. So some of the given here techniques of predictive modeling does not cover GAN. These are the other techniques which are used. Okay. So next, what are the common challenges in data collections? Are noise and inaccuracies in sensor reading, outliers and missing data sets, and environmental factors affecting sensor performance. Okay. So mostly we have analyzed all this. I think so with this, I'm covering up what are the challenges and how sensor data is collected, how the sensor data is pushed into data analytics tool, and then finally uh, the user experience, how to project the user experience. Any doubts you have or anything to be explained? Now the session is open to questions.
Is there anybody?
Any questions related to the presentation, Internet of Things?
I think so. Nobody is there.
Okay, fine. If you have any, if you have your own doubts, if anyone is working in Internet of Things or security, cloud computing, or any application kind scenarios, I work in this particular application, how to implement any ideas you need for your project. The session is open to all.
Sasi sir,
Yes, sir.
somebody question. Then I will come back to
How
you.
to apply for projects. Okay. So, what kind of a project it is? Is it about a consultancy project or funded project? Okay, it is a generic question. Okay, fine. Funded projects. So, funded projects are always called for a theme. Okay, one by one, I will be answering the questions. So, funded projects are usually on a theme it is being called for, and it has a wide spectrum. Starts from language to deep technical societal impact solutions. If you take, for example, I need to monitor, sorry, government need to, DST will be rolling out a project which used to monitor the water quality of Ganga. Okay, so the theme has to be covered, and we need to show, in case if I am writing an article for the same, I need to show that I am from a chemical background, or I am from electronics background, which I have I'm able to work with various type of sensors and Internet of Things in projecting the data. These two niche areas has to be part of investigator and co-investigator. Okay, investigator should be a proper person who works in chemistry, and a co-investigator should be a person who works well in Internet of Things. If this is the combination, these two profiles have to submit on their own. So, what are the supports that we our principal investigator can do? What are the other parts where the co-principal investigators can support? This is the thing. And if you are applying for a funded project, for sure, your resume should be very strong. These many papers I have published. My area of expertise is very strong in the related theme. Then for sure you are able to get the project. If it is a consultancy project, it is entirely different. It is towards a solution. The industry comes up with the problem, and you are going to provide a solution to the same. So in the second scenario, here there is no prior experiences needed, whether you work in that area, not working in that area. That is not a big deal. But the thing is timelines. You have to project a proper project description to them to acquire the same. That's it. Next is in IoT scenarios, what is the possibility of outliers in data? So outliers are nothing but there is a data which you are not fond of. We call them as outliers.
Sir, a small doubt actually.
Yes, sir.
Uh, Whenever we are going for funding project related with IoT,
Yes, sir.
actually they are not giving the first preference related to IoT. So they are always seeing on artificial intelligence or ML like that. So how we can make an funded project IoT to a better one?
Sir, actually, to say right now, all the funding organizations are looking for multidisciplinary research projects. So if there is a project rolled on, they don't need just an electronic expert to be sitting there. They don't need just a cloud expertise applying that. You have to find who can support the project throughout. Okay. For example, if you're doing for an agriculture, there is a proposal that uh, 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 government is going to collect, or government is going to support a project to find how to predict rainfall in Salem so that they are able to identify which what type of cultivations they can support. Okay, paddy, sugarcane, whatever it is. It depends. It is creating a seasonal impact in boosting the cultivation. For this project, for sure, you need an agriculturist. Then you can put up a data analytics inside. Who is a data engineer? You can call a data engineer to be the part. Similarly, you can have an electronics guy who takes care of all the sensors and again, cloud architect, again, a cloud data architect, a cloud architect, and even a GUI expert. If government has to support the farmers through an app, a GUI expert who creates a very good app. Only these combinations, if you have, and their expertise is very good in the reflecting in the resume, for sure you can get the project, sir. So any other questions? Tools for visualizations. Okay, fine. So it is already there in the slide. Yeah, you can use any tool kind of popular visualization libraries I have given, Python or JavaScript. You can use any of these. Is there is any alternate for MQTT? Yeah, CoAP is the another one protocol, which is also a lightweight protocol. CoAP. CoAP is a lightweight protocol, which is an alternate for MQTT, or even in case if you're using socket programming kind, you can go for HTTP2. Some of the applications in Internet of Things, they used to use web servers. So to send the data to web servers, you can use HTTP. So obviously HTTPS service. Which sensor is best for agriculture soil monitoring? Okay, it depends on whether you are going to monitor the quality of soil. In case if you want to monitor the quality of soils, you need to know what are the gases which are getting emitted there. So you need gas sensors. If you want to find fertility of the soil, you need pH sensor, gas sensor, pH sensor to find the fertility of the soil. Then, in case if you want to find soil moisture ratio, or whether the soil is wet, most effective sensor to determine location and obstacle to avoidance. Okay, ultrasonic sensor is the best one for detecting obstacles. Regarding location, all is GPS dot. If the distance is short, you can use higher sensors. So can we end up the session?
I think so. No more questions there.
Yes, sir.
Is there anybody? Okay. Sir, do you have any idea about the GAN? That is a General Adversarial Network, sir.
Oh, yes, sir. Yeah. Actually, to say, first they need to know how the data to be presented. That is why I haven't covered. And session-wise, everyone is going to address GA.
Hmm.
So first, let me. I thought first let them know about how Internet of Things work. What are the different parts in Internet of Things? How data is collected? How data is presented? What are the various analytics that can be applied? So this can be an eye opener for all the newcomers. Then later, if they look over other lectures, for sure they will understand how the data can be used. Sridhar sir, yes sir, you're right. I think so many have. Mrs. Rajeshwari, Kalavani ma'am. Yeah, what are the questions? Please. You raise the hands, no questions.
Yes, sir.
Okay, so then you can end up the session. In case if they want to reach or any doubts is there, for sure you can reach to pencil bits and you can get connected to me.
Okay, sir. Okay, sir. Thank you. Thank you.
Thank you, sir. Thank you.
Thank you so much, sir, for your wonderful session.
Okay.
Feedback link has been posted in chat box, sir. So dear professors can follow it. And tomorrow's session will be by afternoon 2 p.m. to 4 p.m. We can join on the same link.
Okay, ma'am. Thank you.
Thank you, sir. Thank you, Sasikumar, sir.